Hi, my name is Aditya Chanana. I'm a first-year student here in the Masters of Science and Computer Science program here at CMU.
Hi, I'm Shuning. I'm a master's student at Anna here. So today we will be presenting our project, Aperture. It is a voice annotations for cognitive assistance. So basically it works in the way that one user can add annotations on the object they see in their camera, and another user can see the annotations added by the previous user if they are looking at the same object. Example use case that the caretaker can add reminders on the medicines, and the patient can see the reminders when they point their camera at the medicine. To realize this, we need to perform constant image matching, but it will be too expensive to run a mobile device. So our goal is to offload this image matching on cloud-less server. So our system architecture is basically composed of a mobile app and a backend server running on cloudlet. And the mobile app will send the annotations images and the images to match to query sent to the cloudlet. And the cloudlet will check the images, the annotated images, and the query images, and find if they match. If there's a match, the matched image and the annotation will be sent to user mobile app.
So we spent a lot of time evaluating different image extraction, feature extraction algorithms. The goal was to select a feature extraction algorithm that would give us the highest accuracy for our image matching pipeline. For this purpose, we constructed a set of about 60 images. The images were of two categories. In the first category, we had images of the same object taken from different angles, different perspectives, maybe from different distances from the object. In the second category, we had images of different objects, maybe with similar backgrounds or overall images that look similar. So the idea here is to make image matching as complicated as possible so that we can really test the limits of these feature extraction algorithms. So for our database, for our data set, we considered all pairs of images and we checked whether the image matching pipeline gave us the right or wrong results for a given feature extraction algorithm. We benchmarked what we call precision and recall, where precision is for all the matches reported by the algorithm, how many were actually right, and recall is talking about for all of the actual matches that exist in our data set, how many was the algorithm able to identify. And we also benchmarked basically the benchmark time for the different algorithms. So based on these results, we decided on using Kaze features because Kaze had the highest recall and the lowest benchmark time. We also encountered another problem related to scalability, where as the number of annotations we add to our system grows, the time it takes for an annotation to pop up on the app screen grows immensely. So instead, what we decided to do was to incorporate location awareness in that when we send an image frame back to the server, we only try to match it against images that were taken in local proximity of the current user. And when we are able to do this, we are able to support a lot more annotations in our system. And also it increases the accuracy since the rate of false positives goes down since you're really restricting your search space. Okay. So we will go ahead and add an annotation here. So we will say, remember to take medicine. And then we'll just add this annotation right here. And that gets sent back to the server. And when we have this example, I was the caretaker, and then we have another person who the annotation is intended for who comes in and uses their phone. We see that the annotation pops up, and we also get a text-to-speech reminding the patient to take their medication. So as you can see, as we move the camera frame around the medicine box, we still get a match, and we see that the actual matching time is slightly under half a second. But if we disable location awareness, so that we are actually trying to match against all frames in our data set, the matching time increases immensely by almost an order of magnitude. So we are seeing matching times of over 3 seconds now rather than just half a second because we are trying to match against 113 annotations that we have added to our system versus by enabling location awareness, we are only matching against 3 annotations that we have added around this location. So in terms of the challenges that we encountered, a lot of feature extraction algorithms that we found in literature did not have implementations that were ready to use. A lot of them were also targeted at classification rather than the purpose of image matching that we had in mind. And then also we were working with a lot of code that hadn't been maintained for many years. So we had to do a lot of work resolving dependency issues and also rewriting code. In terms of future directions, what we would like to do is maybe permit more than one annotation to match the current camera frame. We want to maybe add some privacy because right now if you add an annotation, all the other users of the system are able to see the same annotation. So maybe you can have the ability to share an annotation with specific people, maybe just your caretaker, for example. There's other things like we would like to add the ability to delete annotations. Right now we only have the ability to add annotations. Maybe we can have the ability to add an option to add a time to live parameter so that annotations eventually expire.